A tipping point is a feature in life, in the atmosphere, in the climate, that when you push it gently and nudge it a bit more, suddenly it tips, as the name indicates. I can give you two good examples of tipping points from your everyday life. Riding a bicycle. Bicycles have tipping points. And when you learn to ride a bike like I did when I was a young lad, I actually experienced a tipping point because I didn't know how to do it quite properly, and I wobbled a bit too far, and the bike goes boom all the way over. For those of you around Canberra or other parts of Australia who like to go out and kayak, you also know what a tipping point is. Kayaks are very stable to a point, and you can nudge them a bit and tip them a bit and they're fine. They come back to what we call an equilibrium state. But when you tip them too far, they don't stay there. They go all the way over and you're under the water. Now we can see tipping elements in the climate system as well, and they come in three different types. One are large areas of the biosphere, or large ecosystems. An example of that is the Amazon rainforest. Well, how does that tipping point work? Well, it's very stable, and it has an inbuilt process that increases its stability. That is, as the name indicates, it needs rain to be a rainforest. Half of its rainfall comes from evaporation from the forest itself, so it recycles in a big cycle. The other half comes from the Atlantic Ocean. So how does this work? Well, as long as it gets enough rainfall, it's stable as a rainforest. And you can vary that rainfall up to a point. But once you cross that point, it gets too dry, it starts burning, it loses its ability to evaporate water, and you see the cycle goes the other way. So the feedbacks start destabilizing. Unfortunately, that's what's happening now to the Amazon forest. Another one is ice, and we talk mainly about the big polar ice sheets. A good example of this is the ice that floats on the Arctic Ocean. So the North Pole is actually an ocean or a sea, but it's covered in ice all year round. So that means in the northern summer, when it's light 24 hours a day, that ice reflects the light and keeps it cool up there. But as we are heating the earth with our greenhouse gases, that ice is starting to retreat in the summertime. So now when the sunlight hits it, part of it is ice, but a growing part of it is dark ocean water. That absorbs the sunlight, much more of it, and that heats the regional atmosphere, which causes the ice to shrink even more, which absorbs more sunlight, and you can see the feedback working. The third one is ocean circulation and atmospheric circulation. For us in Australia, that's important because we are affected quite strongly by ENSO, El Nino and Southern Oscillations. And they may have tipping points too, which are much harder to work out. But one circulation that we know has a tipping point is the Atlantic circulation, which operates down the north-south part of the Atlantic. So it brings warm water up to the north, which keeps Scandinavia habitable, and it takes cold water down to the south, which keeps Antarctica frozen. So it's a good thing to have that circulation, but it's already weakening. We can measure it since the 1950s, and it's weakening because of ice melt. Because the Greenland ice sheet, as it melts, is dumping a lot of cold, fresh water onto the North Atlantic. That sits on the top because it's lighter than the salt water, and that acts to slow the circulation. This gets us all the way back to our starting point, the Amazon, because there, as the Atlantic Ocean circulation slows, less rainfall for the Amazon, and that adds to that tipping point.